All right, I want to derive another kind of identity. Seems like a lot in this section. Going from what are considered the power reducing identities to a half angle. I'm just going to do one with an example, and then if you need more, we can talk about that in class. This was the power reducing identity for sine. And if I wanted to do a half angle, so I'll show you an example in just a second. If I took the square root of both sides here, take the square root here, take the square root here. If you remember from your deriving the quadratic formula days, if I take the square root of something on this side, I have to allow that it could have been positive or negative over here. That's the half angle identity for sine. So if I wanted you to tell me what is the sine of 15 degrees, remember earlier we might have chosen to do a difference identity to say cosine of 45 minus 30. Well, there's another way of doing it. I say it's either positive or negative. Square root of 1 minus the cosine of, hey, twice as big as 15 is 30. I know that. Now, do I go positive or negative? Well, I know that sine in the first quadrant, from all students take calculus, all of them are positive in that first quadrant, so I know it's going to be positive. If 15 degrees was in a different quadrant, I might have chosen something different, but I might have chosen the negative if it was in something in the third or the fourth quadrant. But it's not, so I know it's positive, and in this case I'm not even going to write the positive, I'm just going to erase that. I know the square root of 30, or excuse me, the cosine of 30 is square root of 3 over 2. And so if I were to simplify that, that looks really ugly right now. I could say that, let me get a common denominator here. So I would have 2 over 2 minus the square root of 3, all divided by 2. And when I flip and multiply, that's the same thing as square root of 2 minus root 3 all over 4. I can simplify the square root of 4 to be the square root of 2 minus the square root of 3 all over 2. Now that may seem uglier or look uglier to you. There are some angles that finding the half angle identity is the only way that we're going to do it. Sorry, again, I keep going off the bottom. That's going to be where I have square root of 2 minus square root of 3 over 2. That'll be the same value in a calculator that we got from doing the sine of 15 degrees using the sum difference identity. It's just a different way of doing it. Now, let me do one more example that you couldn't use sum difference. Suppose I wanted to instead use, do the sine of 22.5. So again, it's in the first quadrant. I'm going to use positive, and I'd say 1 minus the cosine of 45 all over 2. Because 45 is twice as big as 22.5. I know that's square root of 2 over 2. Okay. If I multiply, I guess I'm just going to do it like this. Multiply the top and the bottom by 2. That would give me square root of 2 minus the square root of 2 all over 2. Because the denominator would be 2 times 2 or 4. The square root of 4 comes out as 2. You cannot get this value by doing a sum difference identity. So understanding the half angle identities is a good thing to know. Each one of the half angle identities, so I just did the one here for sine of A, but for cosine is very similar. So you can still see on the screen, right? The sine of A is plus or minus 1 minus cosine of 2A over 2. If I was going to do cosine of A, that's plus or minus. Everything is the same except for that's a plus. And that's based on the power reducing formulas that we already calculated. And of course tangent, your book gives 3 different ways of doing it. We can list it as the sine over the cosine. We can get it all in terms of tangent. So there's different ways, and we'll go through examples of those in class.